Well, it's been an exciting year since I assembled this 3D printer on President's Day weekend in 2019. I've learned a lot in that year, and it's been 11 months, so pretty close to a year, since I installed the webcam and the Raspberry Pi. And I initially started with a Raspberry Pi Zero installed on the case with the INC board because I thought that was super convenient. But and it worked okay for printing and connecting a printer to the internet, which is what it's primarily for. But with the webcam, not very good, and time lapse and especially octolapse, very, very poor. It started to affect the quality of the prints, or even causing prints to fail. So that was completely out. I upgraded to the Raspberry Pi 3 Plus, which I really expected to fix all of my problems, because I've had a lot of experience with those, and I've used them as a desktop, and I've done a lot of video streaming, so I expected it to handle that no problem. And it mostly did. It fixed all of the problems, but I still had to slow webcam streaming, both on the OctoPi interface, and if I just hit the webcam stream, directly on its port on the network. So that really surprised me. And so one of the things that's kind of been on my mind over the last year is to investigate that. And so that's what I'm going to do here. So I want to share the story of how I got to the bottom of this problem. And in order to do that, I'm just going to do a few video clips where I show a demonstration of the problem, and then I want to show you a test rig I built to examine the problem, and show you how I collected data from the test rig while I did some tests, describe the tests that I did, and then show you how I used that information to pick the proper solution to the problem. I've already solved this problem. I already know what the root cause is and everything in it. So I'm just going to kind of share the journey that it took me through in order to accomplish that. Okay, I'm going to now attempt to demonstrate the exact issue or phenomenon that I was speaking of. So we've started a timer over here. We've got it running there, and you can see it's counting the seconds. And then over here on my computer, I'm going to go to the webcam view, and we should see that pop up. There it is, and you can see it's already several seconds behind. And that's what I'm talking about. It's not only is it behind, it's running very slow. So we're, creating 10 frames a second, and if you count how long it's been sitting there at 14 for so long, but you can actually count and watch it 1/10 of a second count each one. So you can see each frame come in, but they're just coming in way, way slower than 10 a frame, or 10 a second. And that's the issue, right? So it ends up being way behind. Now I'd like to demonstrate the test rig that I used. I've got a Raspberry Pi 3B Plus connected with a VGA, HDMI to VGA adapter, and a webcam and a little plastic clamp here. I've got a laptop, and I'm ready to go. The first thing I want to demonstrate is why I was so surprised. So like I said, I've used these things before, even as like a desktop computer in a pinch. And as you can see, it has no problem at all streaming video. I don't have a speaker hooked up, so you can't hear anything, but I just picked the first video that was on YouTube homepage, and there it is. It's streaming fine. It's keeping up. It's halfway decent video quality, right? Sure, it buffered for a while and it was behind, but it's able to play at the normal speed, which was not happening at all. So let's do a little demonstration here with see if we can kind of transport the problem to this Raspberry Pi and see if it's an OctoPi problem or a Raspberry Pi problem. Is kind of what my idea here. So I have downloaded mjpg-streamer. That's the software that OctoPi uses, and just run it on the command line here. And we run mjpg-streamer with the output to HTTP, and we have input Raspicam, which is the Raspberry Pi camera. We're going to hit that. Now we're running that. I'm going to go ahead and start my timer. And real quickly, I'm going to hit the web page here. I'm going to hit it locally first. And so I'm just going to type in localhost. There it comes up already because I've done it before. There's the MPEG-J streamer running. I'm going to hit the stream. make it full screen. I think you can see it's pretty much on real time. It's just a slight delay there, not quite a whole second. And you can see it's keeping up though. It's able to keep up no problem. So it's not really a Raspberry Pi problem. It's not like it's not able to generate the data fast enough. That doesn't seem to be the problem. Let's try it over here on our laptop and see whatever it is. How about that? The address is right there. We'll hit it. Yep. Oh, that's not my mouse. I'll hit the stream. And I'm going to wait for that. I'll hit full page here. And there it is. And yeah, it's 3-4 seconds behind. And you can watch it over here. It's definitely not updating once a second, right? I mean, it's not, yeah, sometimes it's updating more than once a second, but it's not updating 5 times a second. Well, my battery's getting low here, but yeah. So yeah, you can see there the several second delay there. So it's not quite as bad, and the reason it's not quite as bad, I didn't mention it here, is this is running with the default settings, which happens to be 5 frames a second, and OctoPi happens to default to 10 frames a second, which of course makes it even worse. And in fact, if I start it with 10 frames a second, it will be worse. So those are the kinds of experiments that I did, and I'm going to discuss these experiments here in a minute, but I just wanted to show the test rig and how it works. Okay, now I'd like to demonstrate how I got the data during each of these tests that I did and how I analyze the data. So this is a program I use. It's called Grafana. Behind the scenes, I'm running a program called Prometheus and a plugin for it called Prometheus Node Exporter. I'm not going to talk too much about that because that deserves its own video. It would take a lot of time. I just want to call out I'm getting some system utilization metrics here, percent CPU, memory used, things like that. And this was running all the time. And if we go back and look at the last few hours here, this is the video clip I did a few minutes ago. Let me just go over here where it's a little easier. And I want to select the time range around that time. And we can zoom in on it here. And we can kind of look at what's going on. And this is how I correlate the data to the event, right? So the first thing I did was I was demonstrating why I was surprised, right? And so I started to stream a video from YouTube. And so we started to see network received bytes per second climb from 0 up to, around 100 kilobytes per second here. And that's that blue line there. The blue line is WLAN 0. That's the wireless adapter. The green line, ETH0 there, that's the built-in Ethernet adapter, but that's not plugged in anything. That's the wired adapter. It's not plugged in on this particular case. And the orange line there is the loopback adapter. And that's what happens when you hit localhost. And you remember, after I did the YouTube video, I started mjpg-streamer, and then I opened up a web browser, and I started looking at the JPEG stream, the webcam stream, on localhost, and look how much more data there is. So this is really the crux of the issue here. So why I was surprised is that I kind of was expecting the webcam to be a similar workload as, say, streaming like a YouTube video. But we can see here that is not the case. That was a false assumption. The YouTube video only required 100K a second, and we were able to stream that in real time. Whereas here with the JPEG streamer's webcam, we're hitting 640K easily, and we're seeing it here on the local loopback adapter. So what's nice about the loopback adapter, there's no bottleneck there, right? It's just a process-to-process communication. It doesn't actually go off the chip, and so there's no bottleneck, and we can really see what's trying to happen, right? Right. And so then again, when I opened up my MacBook and we start trying to get that data off of the wireless network, you can see here, I peak out around 220 kilobytes per second, right? And I've gotten a little more than that. I've gotten, certainly 300 and some K over the wireless adapter on occasion. But that's about it. And you can see that's not enough. That's clearly not enough to be able to keep up with the amount of data that mjpg-streamer is creating during this webcam stream. And that's the problem. And so the question is, what am I going to do about it? I could try to fix the network bottleneck issue, but keep in mind, I want the flexibility here. I want to be able to just throw this thing wherever the 3D printer is and not worry about the quality of the connection and things like that, and just have it work. This thing just needs to work for a diagnostic tool, so the video quality only needs to be good enough for me to see what's going on. So I think I'm going to tweak the video settings and see if I can get it to send data that's more in line with what we saw with the streaming YouTube video, and see if that works. So here's the mjpg-streamer documentation for the Raspberry input plugin. And here we can see some of the settings that are available to us that we can use to tweak its performance, what it's going to do. And the first thing we can do is we can change the frame rate. Notice, for example, that when we did our previous test, we did 5 frames per second, worked better than 10 frames per second. That makes sense because it would produce less data. We can change our resolution, and we can change the JPEG quality. This use stills is just going to make things worse, so we're not going to worry about that, and not going to worry about the full screen preview. So there's some other things we can change, but I don't think any of this is really going to make a big difference in the amount of data. I think these top ones are going to be the ones that we're going to play with. And so those are the ones that I played with some of my experimentation. And the biggest one that I was worried about, or that I thought was going to do the most for me, was the quality, and I was correct in that. That turned out to be right. And so I ended up just kind of sticking with a 320 by 200 resolution, and then I think I was using 5 frames a second, and I just varied the quality 10% at a time. And so here we have 10%, and you can see the LO there is at 40K, and it's pretty solid at that. And so I let that run for a little bit, right? And then I switched up to 20%, and I got almost double the throughput there, 78. And then I switched up to 30, and then 40, and then 50, and then 60, and then 70. Notice that it's not jumping up as much. Then I went up to 85. I went 15 there because the 85 is a default, and I just wanted to use the default setting. And then, just to double check things, I went back to 640 by 480. So now I'm at the default settings except for the resolution, and I come up to here, and I'm running 5 frames per second, and 640 by 480. So I'm just using the software defaults, and I get 780K. So I put this into a little spreadsheet. And the reason I did this is just to kind of keep track of it for me. And so what we're seeing here is just to kind of validate that my metric collection is working, and that I kind of understand what's going on, right? And so this is everything we expected to see. So if we change our resolution from 640 by 480 to 320 by 200, well, that's a fourth as many pixels, right? So we get about a 4 times reduction in data, and that makes perfect sense. And over here, again, as we increase the JPEG quality percent, we get kind of a linear response in terms of amount of data until we kind of level off here. I'm not really sure why we're leveling off there. Not sure I really care because this is already way too high. So we're not going to be able to use these values anyway. So the values we're going to be using are on this line, and this just tells me I can use lower and lower JPEG quality and get lower and lower kilobytes per second and get within that bottleneck, right? That's my goal, is I want to fit within the bottleneck. We've looked at the settings that we can change, so let's give it a try. So what I'm going to do is open up, already got a shell opened up here to the OctoPi, and we're going to do a PS. We're going to look at the process that's running, and we can see it's running with the default settings. So it is passing in this frames per second 10, and that's why we had 10 frames per second. Everything else is the default. So we'll get 640 by 480, we'll get 85% JPEG quality, and we'll get 10 frames per second. So I'm going to go ahead and run that just to get a baseline. And so, oops, I didn't mean to do that. I'm going to hit this first, and then so we're going to go here. I've got the timer over there, so I'm going to hit the web stream here, and we can see there it is. It's running very slow, exactly what we expected, right? And the point of this is just to get a baseline. We want to see the behavior. We want to get the data collected for the behavior, the normal behavior, and then as we change the settings, we can see what kind of effect we're having. So if we don't have the data from the baseline, then we don't really know what we're actually accomplishing, right? So we want to have both before and after, so to speak. All right. So I'm going to go ahead and let this run for a few minutes and collect some data, and we'll see what happens. We've got about 5 minutes worth of data there, and one of the things that jumps out right away is this kind of how it ebbs and flows here. It comes in fits and starts, and that's definitely indicative of a bottleneck I/O, right? It's just trying to shove as much data down the pipe as it can. It consumes consumes the bandwidth, fills up the buffers. Things have to slow down a little bit while it consumes the buffer, and it just kind of comes in fits and starts like that, and it never quite finds a level that it can sustain. And that's because it's a wireless network, and it's not always the exact same bandwidth every moment. So it's got that to deal with as well, and so it just turns into a big mess. So I'm going to go ahead and start playing with the settings now. So the first thing we're going to do is we're going to shut it off. So the way we can do that is we can stop the command. So that'll stop it, and we'll wait for that to go to 0. And while we're waiting for that, we'll look at the settings. And so here's the settings. This is the configuration file, and this is where you configure for the Raspberry Pi camera. And here's an example line. This is a setting I was using earlier. It's kind of a foretelling of where we're headed, but just to be complete, we'll run each test one at a time. So the first thing I want to do is I just want to change the frames per second to 5, because that's what the default is for the software, and that's what our test rig was using. So if we come back to that, we want to see what that looks like. So I'm going to do that. And then I'm going to go ahead and restart the Webcam D service, which is what's running the mjpg-streamer. Now if I do my PS, we can see that instead of running 10 frames per second, we're now running 5 frames per second. Put this minimize. We can see our data is starting to return to 0, and that means that this is probably already stopped. Yeah, so this is already frozen. So I'm going to go over there and reset the timer, and so my iPad doesn't go to sleep on me like it sometimes does. And I'm going to let this data, I'm going to let a couple more minutes pass, and I want this to go all the way back down to 0, so that we're not, so we have a clear delineation from this test from the previous test. See, this is going back to 0. So I'm going to refresh this page. When I do, it's going to reconnect to the webcam, and I have to wait for it to load the page. Sometimes it doesn't load the page right away, and then it kind of skews your result a little bit. There we go. Okay, so it's doing perhaps a little better, but we can see it's still delaying, right? Obviously that took much longer than a second to change. So we're getting 5, each of the 5 frames. If we look here, we can see it counting up 5.2 each time on the tenths. But it's taken longer than a second to get to 5 frames. And so now we're going to do the same thing again. We're going to let this data run, and we're going to see. And I'm kind of expecting the exact same thing, right? Because we only changed the frame rate, and we're still trying to push more data through the pipe than we know we can get, and quite a bit more, right? So we know we can. This would be somewhere around 600K if there was no constraint. and we know we're not going to get anywhere near that. So I kind of expect this to look exactly the same. So I'm going to let this run for a few minutes, and we'll see what happens. Okay, a couple minutes have gone by, yeah, we can see it's already, exactly the same as it was before. We get this mountain range behavior. We're pushing in about the same amount of bandwidth, throughput as before. So we're hitting our bandwidth constraint. Let's go ahead and start changing the settings. Now, what is our goal here, right? Our goal is to get below this bottleneck, right? So let me go ahead and stop this because I want to go ahead and clear that buffer. It takes a while to stop when it's behind like that. So this shell connection is also going over the wireless, so it makes things slow. So I want to get that started. So one of the things that we did is we did this test, and I noticed that I had this linear relationship between the JPEG quality and the kilobytes per second, and I think that's how the YouTube video worked, right? Because the YouTube video, we were watching it, and it was fine. It was decent resolution. It was probably somewhere around 640 by 480 or so resolution, and yet it was playing at full speed, and so it must have been using a lower quality, right? And of course, it's using MPEG, and that's a lot of different stuff, but it's not that different. And so if we look at this here, we can see that this would be how many kilobytes per second I would be running if I was at 320 by 200, but at 640 by 480 I have to multiply times 4. And I want to get below 200 or 300 here, right? So that's, I'm peaking out at 300, so I definitely want to get way below that. And I'm thinking maybe 200, but even then sometimes I can't get 200, but maybe if I could get below 200 and stay there, it would be okay. So that's kind of my first goal. And so I think I can do that by using 10%, right? Because at 10% at 320 by 200, I was using 40K. And so if we multiply that times 4, we'd get 160K, and that's below 200. So let's try that. Let's try 10% and see if our throughput is anywhere closer to 160K, and see if it's any more consistent and not jagged like this. That's kind of what we're hoping for. So let's go ahead and give that a try. So we'll bring up our Raspberry Pi shell, and already you can see our buffer's clear, so we're good. So we can go ahead and edit this command again. So the file here is in the boot directory. It's called octopi.txt or octopi.txt, and so we'll add to this quality 10. We're going to try a quality of 10%. And now if we set that, and then we do a start on the Webcam D, and we do a PS. There we go. So now we have a frames per second of 5 and a quality of 10%. Minimize this. Come back over here. Now this is completely frozen here, so if I refresh, it should reconnect. So we'll refresh. Now it's going to reload this web page. I got to wait for it to reload the web page. And it's taking a little bit. There it goes. Okay, and there it is. And yeah, we had a little bit of a fit and start there, but that could have been here at the browser. So we don't want to read too much into that. We are getting a little bit of a delay there. And some fits and starts. So we're going to let this run for a little bit and collect some data and see what it looks like. So we'll let that run. We can see what's going on here. Yeah, it's, we're getting about 150. That's pretty close to what we were expecting. All of a sudden I'm getting more here. I think that's because I refreshed the page there. But yeah, it's not working too well. It's not really working any better than it was a minute ago. And then it took a big dive bomb. And now it's trying to catch up. And of course that made it overshoot, right? And so it's not quite working well. So that means we're closer. It started to be a little bit smoother there, and before it started messing up. So I think we're a little bit closer You know, it was working a little bit better. We're definitely getting a little bit faster frame rate here, right? We can see that. But it's still behind and it's still not quite keeping up. And yeah, I would say it's probably averaging about 160, but it's just not able to keep up with it. So let's go a little bit farther. We'll just keep, you know, until we get it right. So what I wanted to do, let's stop it again. There we go. And then while we wait for the data to subside, we will edit the settings, and we'll go all the way to 5. And you can see I was using 5 before, so that's because that's kind of where I landed the first time. It seemed to work pretty good. Let's see if it does again. And by the first time, I mean I've already done this one. So like I said, I've already solved this problem once. So now we want to start. Do our PS. Alright, so now we've got frames per second 5 and quality 5. And we're going to minimize this. Our data is just about to 0 there. Our timer should be stopped here. I'm going to go reset the timer real quick, and then we'll give this a shot. That'll give me a second to let this 0 out. Yeah, we're getting close to 0 here, so I think we can start the next test. So we've already restarted the daemon, so we can go ahead and hit a refresh here. Let's hit refresh. Let this thing start. Now again, we're refreshing the whole page over the Wi-Fi, so it kind of messes with it a little bit. So we have to bar our judgment until it runs for a little bit. But yeah, so already we can see there's a lower quality. This is the first time I really noticed that the quality was lower. So at 10% quality, I couldn't even tell that it was a lower quality. Maybe if I looked really close. But here, if you look really close, especially at these numbers, you can tell that the quality is not as good. But look how fast it's going, and it's in real time now. You know, I can tell it to do things, and it'll move. So if I can get it to respond to me, it's not for some reason. All right, well, we'll give that a minute. Yeah, we're just started here. So we're going to let this run for a little bit, and we're going to see what kind of throughput we get and how the quality works. But yeah, it looks like it's working pretty good. It's been running for a little while now. It's pretty much in real time. I was trying to control the printer, and I was trying to figure out why that didn't work, and the buttons were grayed out. It's because it wasn't connected. I didn't notice that. So anyway, now I am. And you know, the point here is that I should be able to control the printer, and you can see it move. Yeah, so there it goes, right? So that's pretty cool. It's actually moving in real time. And also we can look at this. We can see a nice flat data here. So everything's moving in nice. You know, we're well under. We're right at 80K, right? And that's what we would have expected, right? Because that's 1/2 of 160, and 160 was 4 times 40. So that's what we would have calculated with our math, right? So our math would have said at 320 by 200. At 10% quality, we would have 40. And so at 640 by 480, we'd have 160. And then if we have that to go to 5% quality, we should be at 80, right? And that's about where we're at. And so that worked out pretty good. So both those numbers worked out pretty good. We were at, you know, around 150, 160 as an average here. And then we were around 80 here. And it's keeping up. This is running really well. You can see it's mostly keeping up. I mean, we got a little bit of fits and starts there, but it's doing pretty good, and I'm pretty happy with that. I think that's about as good as it's going to get. Okay, at 30 minutes, I think this video is long enough. I'll close on the point that 11 months ago, I drew a false conclusion, just based on an assumption that you know, the Raspberry Pi was slow or something, and that was why this was the case. That would have been an obvious conclusion to draw. It turned out to be network. That would have also been an obvious conclusion to draw, but it wasn't really a network constraint so much as it was that it was extra data. So, you know, the surprise came from the fact that it was different than the YouTube streaming experience, and the reason was because there was a lot more data involved, and that was the surprise. And it makes sense when you look at the settings and you realize you're not doing as much compression and stuff. So, you know, a little bit of thought and a little bit of research, everything started to make sense again. So it's really easy when you're troubleshooting a problem or something like that to get on a wrong turn. And if you don't have something that's giving you data or something that's keeping you grounded in reality, it's really easy to get really confused and turned around just for those reasons. So that was really the kind of the point. It's just that you know, these tools exist and they're out there. You know, they're free to use and it's easy to use. So it's you know, it's pretty easy to kind of see what's going on in these computers. Sometimes it seems like a giant mystery, but you can actually figure it out. So I want to thank everybody that watches. If you've been watching this video and you've made it all the way to the end, congratulations. It's a long video. Please, you know, subscribe if you like these kinds of videos. If you want to see more videos like this one, let me know. Maybe not as long, but I am going to make a video about Grafana and Prometheus and how I set this up, and it may be another 30-minute one. I don't know. We'll see. Thank you again.